Our next speaker will be Anne-Marie Walters, Industry Marketing Director, Process and Resources, Bentley Systems. She joined Bentley in 2004 and is responsible for the marketing and positioning of Bentley's solutions and products that address the needs of the process, power, and industrial markets. MS Walters is a chartered chemical engineer and is frequently a guest speaker at industry events such as this one. Please welcome Anne-Marie Walters.
So, namaste. Thank you to ARC for having me back to speak again, for you guys listening to me again. Last year I spoke about, and over the past couple of years, I've spoken about Bentley's going digital strategy and going digital. This year we're talking about digital twins. We weren't talking about digital twins a year ago because Bentley didn't believe, as a CAD vendor, we didn't really do the digital twin of an asset. We did the simulation, the CAD models, that kind of things, but not the digital twin of an asset. Now we're talking about digital twins because we have integrated the reality modeling that I've been talking about before with the engineering environments and operations environments to truly produce what we believe are true digital twins. So what is a digital twin? I'm going to go through a bit of this. So first of all, you have the digital representation of your physical asset, basically. So that is the models, but it has to be a true reflection of your physical asset itself. In order for it to be a true representation of your physical asset, it has to be continuously surveyed. Your physical asset is constantly changing, constantly new operational information is coming in, new things are happening to your asset. So it's constantly changing. So you need to constantly be updating the digital information you have about your physical asset. And then once you have all of that information, use it, and a lot of the speakers before have mentioned machine learning and artificial intelligence. Once you've got all of this information about your digital asset, you can start applying machine learning or artificial intelligence, looking at all the data that you've got coming in about your physical asset, and you can gain greater insights and use the digital twin to help you predict failures, improve and optimize performance. So for us, that is the definition of a digital twin. It's more than just the models you've got within the computer. It's also all of the operational information and the insights that you're gaining from it. So these are the sorts of inputs into the digital twin: the engineering information, which is the engineering technology, which is what Bentley's really good at; operations technology from your sensors; the information technology from your work order systems, that kind of thing. Then using the digital twin, you have all of your 3D, augmented reality, virtual reality, X-reality. I'm not entirely sure what XR is actually, as well. But then for a digital twin to be really useful, looking at how things are changing over time gives you greater insight. So you also need the timeline of change with your digital twin, and as I mentioned before, providing the basis for analytics and greater visibility into how your asset's performing, so you can optimize and predict failure. So these are all the stuff that goes into a digital twin. Some digital twin workflows that we have in the process industries. I'm from the process industry background. Bentley covers all infrastructure, but these are some examples of where digital twins are providing values right now in the world of the process industry. On the left-hand side, you can see in the world of operations the huge benefits in terms of health and safety training, operator training, planning maintenance, planning your shutdowns, verifying you've got all of the information before you actually start your shutdowns or your maintenance. Then on the more capital project side, which is where digital twins have more been used, if you like, you've got the planning process capturing what you've got there in order to figure out what you could possibly do with your existing asset. Around once you have everybody sharing information in a digital, particularly in a 3D world, you get much better collaboration and stakeholder engagement. you can also start to simulate and predict and work out whether something's going to fail in terms of a simulation environment as well. And then in the construction side of things, looking at simulating where logistics might happen, checking progress, doing status checks, that kind of things. These are all new workflows, or more enhanced workflows, I would say, which digital twins are enabling today in the process industry. So how has this all come about? So I'll let this slide build. So we used to have sort of 15, 20 years ago, desktop devices. Everyone moved from the drawing boards to the computer and did their drawings, and that was CAD. You then have servers, and this is probably most commonly used today. The desktop devices are now linked with servers. You've got everyone sharing model-driven processes, and you have BIM. Now you've got literally unlimited compute power in the cloud, and you've got a lot more. You've got data coming in, data lakes, data coming in from all over the place, and with the unlimited compute power in the cloud and this data, this is now enabling digital twins. So we're in the era of digital twins with the compute power that's arrived, and the move from documents to data, basically. So now I'm going to show you some examples of digital twins. I left you with this last year, if you remember. We have this ability to turn photographs into accurate 3D models, and the ability to now automatically identify things like the antennae and the radars, but also automatically identifying rust. And here you can see it going through the pictures of each of the places of the rust, where the engineer would eyeball the 3D model and figure out which are the most serious parts of rust that to save someone going up the control tower to actually, or the communications tower to actually determine whether what needs to be done. All of that can be done from the 3D model from the 3D model captured by a drone. If you remember that, automatically identifying the rust and bringing the attention of rust to the engineers. Now, where we're at now is with what we mean with a digital twin of this asset is if you've continuously surveyed it. So let's see if this. So I'm going to go back again. So in July 2018, this was what the rust on this antennae. In November 2019, you now have this rust on this antennae. So now you have the digital. This is what we mean by continuous surveying, and having this kind of technology automatically seeing the progression is so much clearer. I'm just going to, because I like this particular video. It's really clear seeing how that rust has progressed over that year and 4 months or so time frame, basically, and having the computer not only show you this, but also automatically also be able to highlight this to you, and you can really see how this has changed over time, is, I think, a very important step forward in terms of digital twins and what we mean by continuous surveying. Another example, and this is going on right now, this is a big construction project that is happening in Pennsylvania in the USA. It's Shell's largest onshore construction project. It's a big ethylene plant. It's around 450 acres. They are in the middle of construction, and they have a drone surveying company, iBot Aerial Solutions, flying the site twice a week, creating a reality model of the construction site on a twice-weekly basis. And so they're continuously surveying the construction site, and they are collecting the information, able to identify track construction progress has what's actually what have I been billed for actually been built, that kind of thing on this twice-weekly basis. Also be able to identify issues and that sort of thing, and also very importantly, they are capturing the history of how this plant is being put together, particularly for operations and maintenance, and particularly for where the underground utilities are going to be or are going for future use. So this, and Shell call this their digital twin. I'm going to play a video now, and it's only very short, about Shell talking about this. Sound. Oops. Sure. Sorry, I go back. Here we go. Right.
Here at Pennsylvania Chemicals, we have the opportunity to be the plant of the future.
The more data we have, the smarter we have to get about managing it.
Everything at a site is located by an equipment tag. Findall uses that as the basis to connect all the different databases. We have complete accountability over 3 million documents and equipment tags on this site.
Now I can go to the tag number for my equipment and immediately find exactly what I'm looking for.
Digital twins use drones to take construction project snapshots on weekly basis, and from these images we create accurate 3D models of the entire construction site.
This enables me to get a top-down view to quickly determine what we need to do. It's very effective.
Any reduction in time will mean literally waiting time that we'll avoid, and we have a safer project too.
So as I mentioned, Shell are using the digital twin of this construction site to track construction progress. They've been using it to check safety issues that have been cropping up, that have been identified. One of the examples they gave was after a new contractor started to work on the site, all of a sudden there was debris falling onto a nearby train track, and they weren't really sure what caused this debris falling onto the train track, but they were able to show that by looking back at the history of how the plant had been evolving, particularly in this area, that the contractor had started working, but he'd not put up the retaining wall. So they were able to rectify that situation really quickly without it causing a problem for the railway, and also to ensure they still were maintaining a very safe construction site. A recent use of their reality model as well has now been the site is bounded by a river, and so they've been looking at the prediction of if the river floods, what happens to their construction site. So this is a combination of the reality model plus software that simulates a water flow, and you can see very quickly if the river floods, how much of the construction site is going to get flooded. And this is a kind of extreme case. What they're actually using it for now is if they know that there's going to be a very heavy rainstorm, thunderstorm, and they're likely to get a lot of water ponding, they do a simulation using the same water simulation software on the reality model and predict where, with the current the construction site's changing all of the time. Piles of dirt and everything are changing, and holes are being dug all over the place, so it's constantly changing. But they have this constant reality model, so they predict. They look at the weather forecast and they predict where the ponding is going to be after a heavy rainfall, and then they can figure out where best to do construction, because they may be flooded in that particular area during a rainstorm. And the rainstorm forecast, so that they can constantly be adjusting and keeping their site safe, but also up to date. So that's a fairly new use of what Shell have been using the reality model for during this construction problem. I'm going to talk a little bit now about what we're doing with Siemens. We have worked with them for many, many years now, and have done this is a reality model of a transformer station in Nuremberg, where we combined both indoor photography and outdoor photography to create an entire reality model of the entire site. And here we've integrated the reality model with the work order systems, and you can see this is there's an issue with one of the transformers. It's linked to the work management system from the reality model, so you can see exactly what we're dealing with. And then it's also bringing in the operations data, the historical information, the manual information, and the and other operational information, so that you have a much better idea of what has caused the problem on the site and what led up to that problem, and hence, before you go on site, what you might do to fix it. So that's now a totally integrated environment based using the MindSphere platform that Samir talked about as well, and combining our technologies. And now this has gone on. So we're now working with, we're now partnered with Siemens to actually offer new services to the market. And last year in November, Joe Kaiser, who's their CEO, talked about their progress, and we're very proud to say Bentley was absolutely mentioned in his 4 key areas of digital transformation within Siemens within Siemens business, basically, and particularly talked about 2 product launches two brand new product launches that we've done with them. The first one is something for the power industry, integrated asset performance management for power plants, basically, announced last October. And basically this combines Bentley's technology for predictive maintenance and our software for reliability and also 3D visualization, as I've showed, but it combined that with Siemens' own knowledge of how to run gas turbines within power plants and power plants themselves. And this has now been launched as a new service. They piloted this implementation at their San Gabriel plant in the Philippines. Basically, at this plant, Siemens are the operations and maintenance contractor. They're doing all of the operations and maintenance for this power plant. They've created an environment much like I showed for Nuremberg, where all of the information is gathered, and they also have added in the failure mode analysis and all the maintenance knowledge that they know, and created this entire digital solution for supporting operations and maintenance, which is repeatable for other plants. And by digitalizing this environment and supporting operations and maintenance, they proved for the San Gabriel power plant that maintenance costs were reduced by 10%. Forced outages, unplanned outages were reduced by 25%, and overall plant availability was increased by 10%. So they and us have productized this service, if you like, for the power industry, and this is a new service. This is all about using digital technologies to transform how you do operations and maintenance, basically. So what about the process industry? And my colleague tomorrow is going to talk a lot more, going to show you in much more detail what we're talking about. This is plant site. So Siemens and Bentley have been working together for a long time in the process industries, and we've combined COMOS with our plant design environment. And I've shown this before. We did a reality model of their Karlsruhe. This is their batch pilot plant, a bit like your ExxonMobil plant. This plant is digitalized up the yin-yang, sorry. It's got all of the sensors on it, it's got all of the data on it, you've got 3D models of it, you've got all the physical components, all the drawings, everything's up to date with this physical model. We created we captured the actual as-is physical model as well, using the reality modeling technology. But you've got all of this data digitalized, and so this plant has got a complete virtual digital twin of virtual representation. All of this data is there. The P&IDs, the wiring diagrams, the digital engineering models, the digital components of all the bits and pieces in there, the product specs and documentation, the sensors, everything like that. So when you combine the two together, you've got the digital twin of this asset. And you'd think that it was completely up to date and perfect, basically. This is what you'd expect. However, what we found, so you've got the as designed model, the as built model, the as continuously surveyed for any changes model, and then what we call the mesh up, the combined digital twin. Even with this plant that's got everything in there, when we combine the as continuously surveyed with all of the digital data, there's still changes that are in the plant that weren't captured into the records, basically. They're not captured in the digital model. So we realized that even if you've got the most perfectly censored digital data, and you've got all the models you can think of, and you think your drawings are up to date, when the plant is constantly, even small changes that operations and maintenance don't think to capture, or it's too difficult to capture back in the main CAD records, if you like, you constantly have this situation where your virtual model is never up to date with the really as is model, and what can we do to make it much, much easier to ensure that the data that a plant person is looking at is completely up to date, and that you're able to capture, and operations and maintenance are able to capture changes very much more easily. So this is when we came out with, we need a new kind of service. We need a digital twin service for the process industries. And this is PlantSight, basically. And it basically it's a truly digital twin solution. It's pulling data from all of the data sources that are there, or whatever data sources you have, as it were, combining that with with the as continuously surveyed reality models and so on, and provided as Samir used platform as a service. We're offering this PlantSight is offered as a digital twin as a service, if you like, leveraging cloud computing and so on and so forth. And the whole point of PlantSight is a solution that helps the operations and maintenance people primarily have access to the most up-to-date information you've got, but also enable them to keep it up to date with the plant changes and pull in all of the operations information that you might have as well, so that they have truly the right information at the right time in order to make the right decisions. And as I say, my colleague Amit's going to show tomorrow is going to show much more detail about what PlantSight can and cannot do, and how it's built. Oops, sorry, that was that. So I'm bringing you back on schedule a bit, so I've got 10 minutes left, which is fine. So what are the analysts saying about digital twins, basically? So I have IDC, Gartner, and ARC here. I think you've heard from all of the speakers that an effective digital twin will enable all sorts of efficiencies, in terms of manpower optimization, improved operations, reduced accidents, and faster time to market. Gartner, interestingly, and this was from February this year, is saying the race to performance via digital innovation has begun. If you don't start digitalizing now, you're going to be way left behind. And the race to going from these, I think, was it pilot paralysis someone used, from pilot paralysis to scalability is really key. And so, and I think a lot of people are seeing this whole environment of digital twins as being able to take people from the pilots to the scalable side. And I agree in terms of the cultural changes that you need to, and assessing your digital maturity is a real key thing to do that. And then we got ARC to write a white paper about specifically creating and deploying digital twins in the process industries. This is by Valentine Delou, basically. It's available. And one of the biggest things that this white paper talks about is how to address what to think about in terms of the cultural differences. So with that, giving you 8 minutes back, I will say thank you, and questions come later. Thank you.